Hello guys, this is Akash. Welcome back to Nurture with Lecture YouTube channel. In this video, I am going to discuss the entire matrices and determinants chapter in a one shot. And in this video, I will discuss what is matrices and what are the determinants and their properties as well as their operations, and how the matrix and determinants are different, and what is a matrix and what is a determinant, and the operations on matrices and determinants, and how the properties of matrices and determinants will help you to solve the problems. This everything I will explain in this single video, and at the last I will discuss some PYQs which are very important to understand in order to crack JEE Mains 2024. You already know the NTA has released the latest syllabus of JEE Mains 2024. In that syllabus, some topics has been reduced, and some topics have gained so much weightage. So in order to get a good marks, it is very important. It is very important to score a decent marks in every chapter. So in this matrices and determinants, the weightage of this matrices and determinants is around +8 marks. That is, you can easily get up to 8 marks in this from this chapter. And you already know the JEE 2024 Elevate batch. In this batch, I already discussed the quadratic equations. You can check in the playlist of this YouTube channel, that is Nurture with Lecture. And this 2024 Elevate batch is specially for 2024 aspirants. In this batch, every chapters will be discussed from detailed, that is from basic to advanced, and at the last the PYQs are also discussed, which will be beneficial for JEE 2024 students. And watch till the end so that you can get a maximum of it. It is very important to watch till the end. That is, I will first discuss the matrices, and second I will discuss the determinants. So watch till the end. So I will discuss each and every topic here. First of all, I will discuss what is a matrix. What is a matrix? Basically, the matrix definition in the book they given as rectangular array of elements. What is the meaning of this rectangular array of elements? Basically, the rectangular array of elements is nothing but we have to arrange. The array is nothing but arrangement. The array meaning is nothing but the arrangement. That is, we have to arrange the elements. Suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose there are 9 elements. So these 9 elements we are arranging in a rectangle. Suppose we are arranging these 9 elements in a rectangle. This rectangular arrangement is said to be matrix. So basically, this is a matrix. That is, the given elements are arranged in a matrix which is a rectangle shape. It is called matrix. And now it is very important. Suppose we have to discuss the one important thing, that is order. What is order? That is, you already know this is a row, this is a column, these are rows, these are columns. So how many rows are present here? 3 rows. So 3 cross, how many columns are present here? 3. So 3 cross 3 is the matrix order. So like this you have to remember. So order is nothing but simply number of rows cross number of columns. You have to just understand what is meant by order. The order is nothing but how many rows are present in the matrix and how many columns are present. The cross of both is called it is just a we can say representation of how many rows and how many columns are present. So basically, this is a rectangle arrangement of elements. And here, if number of rows is equal to number of columns, we can say that matrix is square matrix. It is very important. If number of rows is equal to number of columns, that matrix is said to be square matrix. And square matrix is also a rectangular matrix. That is, every square matrix is a rectangular matrix, but every rectangular matrix need not to be a square matrix. The converse is not true. Every square matrix is a rectangular matrix because the square can be a rectangle, but rectangle cannot be a square. That is the reason the square matrix, it is a square matrix, and the square matrix is again divided. That is, there is a division of square matrix. What is a division? The division of square matrix is triangular matrix. That is triangular matrix. And another division is diagonal matrix. I will explain each and everything. You have to understand very carefully. First of all, triangular matrix. How this triangular matrix is again divided into two types. First one is lower triangular matrix, and the second division is upper triangular matrix. Lower triangular matrix and upper triangular matrix, and this diagonal is again divided into two types, that is scalar, and second one is identity or unit matrix. Identity or unit matrix. I will explain each and everything. First of all, what is meant by lower triangular matrix? I already said how the matrix is represented. Suppose these are elements. Suppose these are the representation of elements, and the order is 3 cross 3 because we are discussing square matrix. So we have to take the number of rows is equal to number of columns concept only. We cannot take other concepts. So 3 cross 3 is the square matrix order, and we are discussing lower triangular. What is meant by lower triangular? Lower triangle is nothing but the elements. These now what I am drawing, these elements is called diagonal elements. Because it is a diagonal elements. You already know. Suppose I can take a square. The square, this is called diagonals. But in this matrix, we only discuss with this diagonal. So this is a diagonal elements. The lower elements in the lower triangle, the lowest elements is 1 second, guys. This is a diagonal elements. In this diagonal elements, what is meant by lower triangular matrix? In the diagonal elements, if upper elements has a value 0 and the lower elements is forming a triangle, upper elements is 0, that is the diagonal, what are the elements present above the diagonal, if the elements is 0, this type of matrix is said to be lower triangular. And what is meant by upper triangular? Upper triangular matrix is, suppose again these are, again we have taken upper triangular, will say this is a diagonal elements, and below the diagonal elements, if the elements is 0 and above it will, if it forms a triangle, then it is said to be upper triangular. This is just a simplification, that is this. And again one more thing I have forgotten, the matrix is, every matrix is defined, that is Aij. I will discuss what is meant by Aij. Basically, what is meant by lower triangle? In lower it should form a triangle, and in the elements which are present above the diagonal elements, it should be 0. And what is upper triangular? Diagonal upper it should form triangle, and diagonal lower it should form the element should be 0. This is just a division. And now I will discuss here only what is meant by Aij. Every matrix is denoted by capital letters. 1 second, guys. Suppose every matrix is defined as capital A, that is capital letters only. This is defined as Aij. What is meant by Aij? For I and J, I is row number and J is column number. So there are so many possibilities for row and column. That is I value can be 1, it can be 2, it can be 3, and J value can be 1, J value can be 2, J value can be 3. Yes. So here if you see carefully, there are so many possibilities. For matrix A, there are so many possibilities. That is, this is a matrix and these are elements. What is first element defined? First element is defined by A, and I is the first, this is the first row. So I value will be 1, and this is the first column. So again J value will be 1. So A11 is the element which is present in the first row, first column. And again this is the first row only, and the column number is second. So A12, and this is A13, like this. Now second row, so A2, and the column is 1, so A21, and again second row, second column, and second row, third column. Again first third row, first column, third row, second column, third row, third column. So like this it is defined. Now the diagonal elements are this one. So the diagonal elements, how it defined? Aij, it is defined as Aij where I equal to J. If I equal to J, then those are diagonal elements. And in a lower triangle, how we can define lower triangle? In this value, the J value will be higher. So wherever J is greater than I, there the element is 0. Aij is equal to 0 there. Like this you can define. And here wherever j is less than I, and there aij will be equal to 0. Like this here we can define. So this is a just representation of the matrix. And now let's come to the important part, that is diagonal matrix. What is mean by diagonal matrix? Diagonal matrix is simply diagonal only, that is the matrix only, but here the representation will be different. The diagonal matrix says that in the lower triangle and upper triangle, what we discuss, the principal diagonal element, the principal diagonal elements below element should be 0. It will be upper triangular, and if above elements will be 0, then it will be lower triangular. But what if both above and below elements are 0? What if below and above elements are 0? And the diagonal elements, there is no proper definition. That is, these three elements will be 0. But here at least one should be non-zero. Suppose these 0, 0 can be possible, but it should be one non-zero. This is a diagonal matrix. That is, what is a proper definition of diagonal matrix? Except principal diagonal elements, remaining all elements should be 0. The principal element should contain 0, but at least one element should be non-zero. It is called diagonal matrix. And this diagonal matrix, it has two types. That is scalar matrix. What is scalar matrix? Same what I discussed here, same here also. But the diagonal elements will become a scalar, constant scalar. That is a, and the remaining elements will be 0, 0, 0, 0, 0, 0. Like this matrix. If a is a scalar, it is said to be scalar matrix. What if a equal to 1? If a equal to 1, it is identity matrix. That is, if a equal to 1, what we can say here? 1, 0, 0, 0, 1, 0, 0, 0, 1. This matrix is said to be identity matrix or unit matrix. Like this, this is a division, just it is a division. Here what we discuss what is a matrix, what is the order of the matrix, how the matrix are different types. That is, scalar matrix has rectangular matrix, and how square matrix is divided into two parts. That is, upper triangular, lower triangle as triangular matrix, and scalar identity matrix as diagonal matrix. What is triangular, what is diagonal, I already explained. This is just a division. Now comes the properties. What are the properties of matrix? What are the properties of matrix? Here we will discuss the properties. First of all, here we will be discussing the additive properties. That is addition properties. The multiplication is more important than addition, but I will discuss first addition. The addition properties. What is addition properties? First of all, in order to perform addition is valid only if two given matrices having same order. It is very important. Suppose I am taking matrix A. I am taking A11, A12, A13, A21, A22, A23, A31, A32, A33. Suppose this is a matrix and it is defined by Aij. I already said. And I am taking another matrix, that is B. B is equal to B11, B12, B13, B21, B22, B23, B31, B32, B33. Suppose this is another matrix and is defined by Bij. Now, order. What is order of Aij? It is 3 cross 3. What is order of Bij? It is 3 cross 3. Now, orders are same. So, these two are eligible to perform addition. How addition is performed, I will say. The addition is Aij plus Bij, and condition is Ai should be equal here. This Ij from Aij is equal to Aij, that is Ij from Bij. That is, every alternate element should be added. Suppose this is the sum A plus B I am defining. What is A plus B? Every element, corresponding element should be added. That is, A11 should be added to B11. So sum will be A11 plus B11. And next element, A12 plus B12. So here if you observe carefully, 1 1 will be equal to 1 1. Like this only the addition will be possible. 1 2 will be equal to 1 2. Similar element should be added. That is, the first element should be added to first element of the another matrix. The second element of the first matrix should be added to second element of second matrix. Like this addition should be performed. It is very, very, very important. That is, we cannot shift the positions. That is, A21 cannot be added to B31. It should be only added to B21 only. These two should be added. This is addition. what I said, main important thing is addition is performed only the given matrices are having the same order. If they are having the same order, addition is performed by just adding the corresponding element. That is A11 is added with B11, A12 is added with B12, like this. And next, now comes the property commutative. Commutative property. Commutative property. What commutative property says? The commutative property says that is addition of A plus B is same as addition of B plus A, because the corresponding elements are adding, but when comes with multiplication it is different. I will explain in multiplication, but understand here what is commutative property. A plus B is same as B plus A, it is commutative. Next, again same, A plus of B plus C is same as A plus B of C. This is also valid, this is valid, this is valid, because it can be commutative, it will be associative. We can associate with any two. That is the addition of B plus C, and after adding plus A, it is same as, first of all you can add A plus B, and later you can add C. So suppose if I take the 2 cross 2 matrix, simple example, suppose 1 2 3 4, and another matrix has 1 0 2 0, and another matrix has 1 3 2 1. Both 3 or 2 cross 2 matrix, because I already said the addition is performed when the matrix is having the same order. So if this is A, this is B, this is C, you can cross verify this. That is A plus, first I will do B plus C. What is B plus C? B plus C is equal to, B plus C equal to 1 plus 1 2, that is 1 plus 1 is equal to 2, and 0 plus 3 is equal to 3, and 2 plus 2 is equal to 4, 1 plus 0 equal to 1. So this is B plus C. Now again I am adding A here. A is 1 2 3 4. What I will get? I will get B plus C is equal to 2 plus 1 it is 3, 3 plus 2 it is 5, 4 plus 3 it is 7, 1 plus 4 it is 5. This thing I got. When what I did first, I did B plus C first. Now I am doing A plus B first. This is A, this is B. If I do addition, what I will get? A plus B is equal to, A plus B equal to 1 plus this 1, this 1 should be added. That is 1 plus 1 is 2, and 2 plus this 2 and this 0 should be added. That is 2. 3 plus 2 is added, that is 5, and 4 plus 0 is added, 4. So this is A plus B. Now I am adding plus C here. That is, for this I am adding this matrix. What I will get? 2 is added with 1, that is I will get 3, and 2 is added with 3, I will get 3. I will get 5, not 5 I will add it with 2, that is I will get 7, and 4 is added with 1, I will get 5. This is, first of all I performed A plus B of plus C. This thing I performed first B plus C, after I added A. If you observe carefully, 3 is same 3, 5 is same 5, 7 is same 7, 5 is 5 same. So these two are equal. Like this you can prove. You can take example of any two matrices, and you can 3 matrices you can take and perform the operation and check whether both are equal or not. And now I checked and I got both are equal. That is A plus B. First after doing A plus B, if you add C, it is same as first adding B plus C after adding A. Like this. Now comes the important concept, that is trace. What is trace? Trace is a sum of diagonal elements. Simple. It is a sum of diagonal elements. That's it. Suppose I am dealing with the 2 cross 2 matrix. Suppose the elements are given as 1 2 3 4. What is the trace? It is defined as A. What is trace of A? Trace of A is simple, is diagonal element sum. Diagonal element sum. So what are diagonal elements here? 1 to 4 are the diagonals. So 1 plus 4 that equal to 5, which is equal to trace of A. Like this you have to find the trace. And it is a 2 cross 2. What is the trace of 3 cross 3? That is 1 2 3 4 5 6 7 8 9. Suppose this is a matrix of order 3 cross 3. Now I have to find a trace of A. What is the trace of A? The diagonal elements. These are the diagonal elements. That is 1 plus it is 5 plus here it is 9. So 1 plus 5 it is 6, 6 plus 9 it is 15. So trace of A is equal to 15. Like this you have to find. This is the concept of trace. Trace is simply the addition of that is addition, or you can say summation of trace elements. That is the diagonal elements. It is called as trace. Now the trace has some properties. That is trace of A plus B. Trace of A plus B is same as trace of A plus trace of B. You can prove it by taking the two matrices. Suppose I will take 1 2 3 4 as a A matrix, and I will take B matrix as 1 3 5 6. Like this I will do. What is trace of A plus B? Suppose to find the trace of A plus B, first you have to add what is A plus B matrix. A plus B matrix is 1 plus 1 it is 2, 2 plus 3 it is 5, 3 plus 5 it is 8, 4 plus 6 it is 10. This is A plus B. Now I have to find trace of A plus B. Trace of A plus B is simply the addition of diagonal elements. So 2 plus 10 8 it is 12. So this is the trace of A plus B. Now it is same as this one. I will prove it. That is trace of A. What is trace of A? Again summation. That is 1 plus 4, it is 5. So trace of A equal to 5 I got. And what is trace of B? Trace of B is 1 plus 6. Trace of B is equal to 7. So if I add these two, that is trace of A plus trace of B, that is 5 plus 7, that is equal to 12. So it is same as this one. That is, after performing addition, finding the trace, it is same as finding the individual traces. This is a concept. And same as a difference, that is A minus B. Trace of A minus B is equal to trace of A minus trace of B. Simple properties. And what is trace of Ka? Trace of Ka is K times trace A. It is very important. K times trace A. What is the meaning of K into A? The scalar multiplication of matrix. That is, suppose the matrix is like this, it is given. Suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose it is A. I have to find 2 into A. In matrix, remember, every element will be multiplied with the given constant. The 2 should be multiplied with every element. Every element, that is 9 elements, should be multiplied with the 2. Now what I will get? 2A. I will get 2, 4, 6, 8, 10, 12, 14, 16, 18. This is the matrix 2A. It is very important. In matrix, every scalar, that is every element, should be multiplied with the given scalar. But in the determinant, it will be not like that. I will explain in the determinant chapter after this matrix completion. Next, what is additive identity? Additive inverse. Additive inverse of A. What is the meaning of additive inverse? Whatever we add with 2A, we have to get 0. That element is said to be additive inverse. So what I have to add? I have to add minus A. So minus A is said to be additive inverse. Suppose if I take example 1, 2, 3, 4, what matrix should be added to get 0? That is 0 is nothing but null matrix. That is 0, 0, 0, 0. What I have to do? Just negative of this. That is minus 1, minus 2, minus 3, minus 4. Which is the negative of A. This is the matrix A. If I do negative, which is the negative of A, if I add both these two matrices, I will get null matrix. This is there. Now comes the important, that is multiplication. Multiplication. Here also very important. What I said in addition. In addition, the addition is possible only when the order of two matrices is same. But in multiplication, the multiplication is possible when the number of columns in first matrix is equal to number of rows in second column. That is second matrix. That is number of, I will write the definition, number of columns in first matrix. Number of columns in first matrix should be is equal to number of rows in second matrix. Just remember this one. If this is true, then the multiplication is possible. Multiplication is possible. That's it. That is multiplication. What is multiplication? We have to multiply two matrices. In order to multiply, the first matrix number of columns should be is equal to second matrix number of rows. That is, suppose this is the matrix. What is order of matrix? 3 cross 3. How many columns are present? 3. So here this those many rows should be present. So suppose I will take another thing here. What is the matrix here? 3 cross 4. If we observe carefully, here the number of columns is 3. Here the number of rows is 3. So both are equal. So multiplication is possible. Multiplication is possible. And after multiplication, you will get another matrix. After multiplication of these two matrices, you will get another matrix. What is the order of that matrix? That is, these 3 will get cancelled. What are the remaining numbers? That is 3, and here it is 4. So 3 cross 4 is the output. That is the matrix which after multiplication. Now I will write one matrix. You have to say whether this one will possible or not. The dashes is nothing but there are some elements. This matrix is 2 cross 2. This matrix is 3 cross 3. The multiplication is possible or not? No, it is not possible. It is not possible. Why it is not possible? The matrix multiplication is not possible because here the number of columns is not equal to number of rows in second matrix. So here the multiplication is not possible. Suppose how multiplication should be performed. I will take one example. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here I will take 1, 0, 3, 1, 5, 6, 1 3 4. Suppose this matrix, here it is 3 cross 3, here it is 3 cross 3, the number of columns is equal to number of rows, and you will get another matrix multiplication that and having the order 3 cross 3 only. What is this matrix and how multiplication is performed? I will explain now. That is, you have to take like this matrix should be multiplied with this matrix. Yes, the multiplication is possible, the condition is true. Now what you have to do, first matrix row should be multiplied with every column of the second matrix. Every column of the second matrix. Every column of the second matrix. That is 1 2 3 will be multiplied with 1 1 1 first of all. 1 into 1, that is 1, plus 2 into 2, 2 into 1, it is 2, plus 3 into 1, it is 3. Completed. The first row, first column is completed. Now first row, second column. 1 into 0, it will be, what will be, what it will be, 1 second guys, I will make the big bracket here. Here 1 plus 2 plus 3 completed. Now 1 plus 1 2 3 should be multiplied with the second column. That is 1 into 0, it will be 0. 2 into 5, it will be 10. 3 into 3, it will be 6. 3 into 3 will be 9. And second column is also completed. Now the first row should be multiplied with third column. 1 2 3 will be multiplied with 3 6 4. So 1 with 3, that is 3, and 2 with 6, it will be 12, plus 3 into 4, it will be 12. So the first row is completed. Now comes with the second row. Again take second row and again multiplied with every column of second matrix. Every column. So 4 5 6. 4 ones are 4. 5 ones are 5. 6 ones are 6. Yes. Again this matrix should be multiplied with second column. 4 into 0, it will be 0. 5 into 5, it will be 25. 6 into 3, it will be 18. Yes. 4 5 6, again we have to multiply it with 3 6 4. So 4 3s are 12, 5 6 are 30, 6 4s are 24. Yes. And next third row. Third row should be again multiplied with first column, second column, third column of second matrix. That is 7 8 9. 7 8 9, if I multiply, I will get 7 plus 8 plus 9 in first element, and 7 8 9 should be multiplied with second column. That is 7 into 0, it will be 0. 8 into 5, it will be 40, and 9 into 3, it will be 27. And 7 8 9 should be multiplied with 3 6 4 here. That is 7 3s are 21, plus 8 6 are 48, plus 9 4s are 36. If I find the total summation, that is 1 plus 2, it will be 3, 3 plus 3, it will be 6, and here 19, and here it will be 24, 27, here it will be 15, here if it will be 35, 35, 43, and here it will be 54, 54, 56, 66. Here it will be 15, 15, 24 here, and here it will be 67. Here it will be 48, 49, 49, 59, 69, 69 plus 36, it will be 15, 4, 10, 105. So this is the matrix we obtained after multiplication of this matrix and this matrix. Like this, you have to perform the multiplication. And now comes the important properties for multiplication. Now comes the important properties. That is, the first property is A and B. Suppose A and B are two matrices. I already said A should have the same number of columns as the same number of rows in second. That is, this should be is equal to this one. That is, the second will equal to first. That is, the number of columns in the A matrix should be equal to number of rows in B matrix. If I do, I will get AB of order how much of M cross P. That is the remaining elements. So this is. And now, is this correct or not? AB is equal to BA. Is this correct? No, it is not correct. But in general, it is not correct. That is, AB will not equal to BA. But in some cases, it can be equal. You have to remember this thing. It is very important. That is, the multiplication of two matrices is not commutative. The multiplication is not commutative. Not commutative. But in general, it is not possible. That is, it is not commutative. But some cases we can get the two matrices are equal. That is, AB multiplication is equal to BA multiplication. But you have to check. But 99% cases it is not correct. That is, AB is not equal to BA. But AB not equal to BA is always true. Always true. But in some cases it can happen. That is the reason why I written general. And now, but this is possible. Associative. Matrix is associative. Suppose if I take three matrices, that is A, B, C, A dot B dot C is same as A dot B dot C. That is, what is the meaning of this one? That is, if I multiply B and C first and later if I multiply A, it is same as first of all multiplying AB and after multiplying C. this thing you have to understand, that is it is associative, that is we can associate any of two and find the things. And next, and one more thing, if what is called as this one second guys, if AB equal to BA, if A equal to BA, we can say A is commute to each other, A and B. A and B, A and B are said to be commute to each other. A and B are said to be commute to each other, and if AB is equal to minus BA, then A and B are said to be anti-commute each other. Anti-commute each other. This thing you have to remember. And next thing, and suppose the next thing is, if AB is equal to 0, that is AB is equal to null matrix. If AB is equal to 0, what does it imply? Is this imply A is equal to 0 or B is equal to 0? No, this is not correct. A multiplication B is equal to 0. A equal to 0, B equal to 0, it is not correct. In general, what we can say? We can say if A equal to 0, B equal to 0, definitely A into B is equal to 0. But there are some matrices. Suppose if I take this matrix 0, 0, 5, 0 and another matrix as 0, 0, 1, 5. Suppose if I take this matrix, if I do the multiplication of these two matrices, it is null matrix. But these two matrices are not null matrices. You can check this one. That is, these matrices are not null matrices. I have taken some example. It is, I think it is not correct. I think 1 second. I think it should be 0 here. It should be 0. Suppose if I take it like this, these two matrices are not null matrices, but their multiplication results in null matrix. So we cannot say that if two matrices are multiplied and we got a null matrix, that does not imply that both matrices are null matrices. It is not correct. And one more thing, AB equal to BA. AB equal to, we can say, once again, it is not this thing. What I am saying here, that is AB is equal to AB equal to AC. Is this imply B equal to C? Can we cancel A? No, we cannot cancel. If B is equal to C, A into B is equal to A into C is true, but this is not given. It does not imply B equal to C. It is saying that AB minus AC is equal to 0, that is null matrix. If I take common A, that is B minus C is equal to 0. Again, same, the previous property, that is A into B minus C is equal to 0. That does not imply A equal to 0 and B minus C is equal to 0, which implies B equal to C. What does it imply? It simply implies it can be a case, but always it is not true. That is A matrix. Here we can find another matrix of which is not a null matrix, and B minus C we cannot find equal. But if B equal to C, definitely A into B is equal to A into C, and this is pre-multiplication, and we can again write B into A and C into A. This is also true, but these two are not same because it is pre-multiplication, it is post-multiplication. That is pre-multiplication and post-multiplication are not equal. And one more thing, that is suppose it is there is a cube. What we can do? A into A into A, we can write like this, or we can write A into A like this, or we can write A square into A like this, or we can write A into A square like this. You can write multiple ways. That is a multiplication property, it will exist. And now comes the important part, that is transpose. Transpose of a matrix. What is a transpose of a matrix? Suppose there is a matrix that is A11, A12, A13, and A21, A22, A23, and another matrix is A31, A32, A33. This is a matrix of order how much? 3 cross 3. Now we have to find the transpose. The transpose is denoted by the letter A power T, which is said to be the transpose of a matrix. This transpose, how we can calculate? The definition of transpose of a matrix is in the given matrix, the row should be now become column and the column should be become row. That is, we have to write row as column. We have to write row. This is row. Now we have to write it in a column. That is A12, A13. That is, if we observe, it is row and it becomes now column. Again, second row is we have to take, and again we have to write column. A21, A22, A23. And third row again we have to take, and again we have to write column. That is A31, A32, A33. If I write like this, this is said to be the transpose of a given matrix. Suppose if I take example 1, 2, 3, 4, 5, 6, 7, 8, 9. If this is a matrix A, what is A transpose? A transpose is simply, we have to take row and we have to write in column. That is 1, 2, 3. We have to take row and we have to take column. That is write in column. Again we have to take row. That is 7, 8, 9. We have to write in column. This is said to be the transpose of a given matrix. And in the transpose, there are so many properties. That is, what is A transpose of whole transpose? If I again do transpose here, that is A transpose whole transpose, what I will get? Again, row is transformed to column. That is 1, 4, 7, 2, 5, 8, 3, 6, 9. If we observe carefully, this matrix is same as this matrix. So A transpose whole transpose, again we will get A matrix only. This is first property. Second property is A plus B whole transpose is same as A transpose plus B transpose. That is, after performing addition, if I do transpose, it is same as performing individual transposes and adding the result. It is very important. And what is A minus B whole transpose? Again, A minus B whole transpose is A transpose minus B transpose. And the next thing is, what is K into A whole transpose? It will be K into A transpose. It is very important. This is a property. And what is A into B transpose? This is a 5-star result. That is, what is A into B whole transpose? In addition, we said A transpose plus B transpose, but it is not in the case of multiplication. This is not equal. That is, A transpose into B transpose, it will not equal. What A into B whole transpose? A into B whole transpose is equal to B transpose into A transpose. That is a reversal property. That is, A into B will be now become B transpose into A transpose. This thing you have to remember. It is very important. This thing you will understand in adjoint or inverse. So many things you will get here. And this is the case. Now here comes the important thing. That is, what is symmetric matrix? What is symmetric matrix? Symmetric matrix is nothing but, in the symmetric matrix, A transpose will become A. And another matrix is skew symmetric matrix. Skew symmetric matrix. In the skew symmetric matrix, A transpose will become minus A. This is the important results you have to remember. And in the skew matrix, in the matrix, if you observe, how we can find the diagonal elements will not equal to 0, and the elements, these two elements will be equal. The opposite elements, this element will be equal to this element, this element will be equal to this element, and this element will be equal to this element. And but in the skew symmetric matrix, if I take the matrix form, how we can identify the diagonal elements? The diagonal elements will become 0 in skew symmetric matrix, and these elements will having the opposite sign. Suppose it is 1, it will become minus 1. It is 2, it will become minus 2. If it is 3, it will become minus 3. This type of matrices are said to be skew symmetric matrix. And every matrix in the universe can be represented as a sum of symmetric and skew symmetric. This thing you have to understand. That is a sum of symmetric and skew symmetric matrix. This A plus A transpose is a symmetric matrix, and this is skew symmetric matrix. Like this, you can find this thing can be written as half into A plus A transpose, and this can be written as half into A minus A transpose. Like this, if I can write, it is possible for me to write like this. Every universal matrix can be expressed as a sum of symmetric as well as skew symmetric matrix. This is the case. And next comes important thing, that is types of matrices. There are so many types of matrices. I already discussed this topic, but there are some important topics. That is, the important matrices are present. Up to now, how many matrices I discussed? Rectangular matrix, square matrix, unit matrix, scalar matrix, triangular matrix, upper triangular, lower triangular. So many matrices I already discussed. But apart from those, there are nearly 5 important matrices. The first one is orthogonal matrix. that is orthogonal matrix. What is orthogonal matrix? Orthogonal matrix, the definition is A into A transpose is equal to A transpose into A. This multiplication is equal to I. If this is the case, it is said to be orthogonal. The condition is like this. Suppose I have given a matrix and check whether orthogonal matrix or not. What you have to do, you have to find transpose of that matrix, and if I multiply both matrix, if I get identity matrix, that is, what is IE here? IE is nothing but 1 0 0 0 1 0 0 0 1. If I get this one, when I multiply A into A transpose or A transpose into A, this matrix is said to be orthogonal matrix. So this is the first case. This is the first matrix, and second matrix is idempotent matrix, and third one is involuntary matrix. Third one is involuntary matrix. I will explain each and every one. Third one is involuntary matrix. Fourth one is nilpotent matrix. Fourth one is nilpotent matrix, and fifth one is periodic matrix. I will explain each and everything. Idempotent matrix. How you can remember the matrix? The orthogonal matrix is simple. A into A transpose equal to A transpose into A equal to I. Okay, it is fine. Idempotent matrix. How you will remember? ID. First two letters remember. ID is nothing but suppose my ID is my Aadhaar card. So if I do square and if I get A, that is same result. A square equal to A. If I get this matrix is said to be idempotent matrix. That is same. Suppose my Aadhaar card will resemble my only. That is my identity will resemble my only. Na? So that is the reason. If I do square of the matrix, if I get the same matrix again, it is said to be the ID, that is idempotent matrix. And what is involuntary matrix? That is IN. That is, if I do square, A square, if I get IN is the order of A matrix. If I do square and I will get I, that is identity matrix, I will that matrix is said to be involuntary matrix. This is a case. And next, third one is nilpotent matrix. Nilpotent is nothing but 0. Nil matlab 0. So A power K equal to 0. That is, if I do suppose A matrix is given, if I do square of that matrix, I will do cube of that matrix, I will do power 4, power 5. At what power the matrix is becoming 0? If the matrix will become 0 at certain power of A, then it is said to be nilpotent matrix, and here K is said to be nilpotent value. And the fifth one matrix, important matrix, is periodic matrix. Periodic matrix says that A power K plus 1 will become A. Remember each and everything. Idempotent, A square equal to A. Involuntary, A square equal to IN. And the nilpotent is A power K equal to 0. Here 0 is nothing but nilpotent, that is 0 matrix, that is 0 0 0 0 0 0 0 0 0. Like this is a matrix. And what is periodic matrix? If I do A power something and I will get A again, at what power? At power K plus 1. And here K is said to be period. Suppose there is a matrix A and at power 5 I am getting it as A again at power 5. So 5 can be written as K plus 1. So K will be 4. So 4 is a period of that matrix. Like this, these are the 5 important matrix: the orthogonal, idempotent, involuntary, nilpotent. Like this you have to remember. Now very important result. You can tick mark as a 5 star. That is A matrix. I am discussing one matrix, that is 1 1 0 1. This is a matrix. This is a special matrix because find A square in this matrix. What I will get? I have to do A into A. So 1 1 0 1 1 1 0 1. What happen if I multiply these two matrices? I will get again. First of all, you have to check multiplication possible or not. It will be 2 cross 2. It will be 2 cross 2. So 2 is equal to 2. So multiplication is possible, and I will get 2 cross 2 as order. So 1 into 1 should be multiplied with this column and this column. Yes. So 1 1s are 1. 1 1s are 1, and 1 into 0 is 0. Next, 1 into 1, it will be 2. Here it will be 0. Here it will be 1. And this is A square. What is A cube? A cube I have to find. It will be A square into A. So what is A square? A square is 1 2 0 1 into 1 1 0 1. What happened if I multiply these two? I will get again 2 cross 2 matrix because this is 2 cross 2 and this is 2 cross 2. These two are same. I will get the resultant matrix order this one. So 1 into 2 will be multiplied with 1 0. That is 1 into 1 it will be 1, and 2 into 0 it will be 0. That is 1. And if I multiply this row and this column, that is second column, what I will get? I will get 1 into 1 it will be 1 plus 2 into 1 it will be 2. So it will be, I will get 3. And here same 0 1. What you have observed, I will write here again. A is 1 1 0 1, and a square is equal to a square equal to 1 2 0 1. And what is a cube? A cube is equal to 1 3 0 1. If you observe carefully, these three elements is same. What is changing? This element is changing. So this if you see clearly, a power 1 I will getting here 1, a square I will getting here 2, a cube I will getting 3. So if I multiply these all matrix, that is a into a square into a cube, if I multiply every matrix, I will get the summation, that is 1 0 1 is same, but I will here I will get addition 4 5 6 up to n. So this entire thing can be represented as n into n plus 1 by 2. So if I multiply power times n, that is a power n, what I will get? I will get matrix as 1 0 1 n into n plus 1 by 2. It is very important. You have to find the pattern of matrix, how it is repeating. Now it is completed. This is important result, you have to remember, important, very important result. Suppose I have to compare with this matrix, the 1 0 1 72. I have to compare. I have to find the n at what power I will get this matrix, that is 172 0 1 at what power. So simply write this matrix and equate this matrix, that is this value should be equal to this one, that is n into n plus 1 will be equated to by 2 is equal to 72. So n into n plus 1 by 2, that is this one equal to 72 into 2, it will be 144. Yes, 2 to the 4, that is 7 to the 14, that is n into n plus 1 is equal to 144. And find n. Find n. So at what n you will be getting this value. That's it. There are so many questions with this matrix. That is the reason I have taken here. And next important concept is adjoint. Next important concept is adjoint here. Adjoint of a matrix. What is adjoint of a matrix? Adjoint of a matrix is defined as transpose of a cofactor matrix. Very important thing. Transpose of a cofactor matrix. Yes? Transpose of a cofactor matrix. What is transpose of a cofactor matrix? So it is cofactor matrix also a matrix. So adjoint of A is denoted by adjoint of A matrix. It is denoted as cofactor. That is cofactor matrix is Cij. Transpose of the Cij is called adjoint. And what is Cij? How you can find Cij? Cij is a matrix. It is a matrix. How it is obtained? Cij is matrix obtained by the multiplication of minus 1 whole power I plus j times minor of that element. I will explain each and everything. I will take one example also to make you understand. Suppose this is a matrix A, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. Suppose this is a matrix. I have to find what? Adjoint of A. So in order to find adjoint of A, what I have to find? I have to find cofactor. Cofactor matrix I have to find. So in order to find cofactors, first of all, I have to find minors. What is a minor's definition? Minor definition is the value. That is a minor definition here. Value obtained after deleting or eliminating the row or column. Very important. So I will write here everything. Minor of A11. I have to calculate minor of A11. What I have to do? I have to eliminate that element row and that element column. These two will be removed. That is this one is removed. And what is the elements present? This value, that is A22, A23, A32, A33. this value is called minor of A11, and second one minor of A22. What is minor of A22? To find the minor of A22, that is 82 present is here. So I have to eliminate this row and this column. What are the elements present remaining? That is A11, A13, A31, A33. I have to write here A11, A13, A21, A33. Like this, every element will contain the minors. And this value, this A22, A23, this value you have to find by cross multiplying this one. That is A22 into A33 minus this one, minus A32 and A23. This value is called minor of A11. And for this value, if I multiply minus 1 whole power I plus j. What is I plus j? I plus j is this one, ij. If I am calculating A11. If I put here, that is minus 1 whole square, what I will get? 1 here, 1 into this value. That is a minor of A11. And if I write every value here, it will become Cij. That is multiplying minus 1 whole power I plus j times the minor matrix. If I do this one, this entire thing is said to be this cofactor matrix. I will get cofactors here. That is C11, C12, C13, C21, C22, C23, C31, C32, C33. If I write every minus multiplication with minus 1 whole power I plus j as like this matrix is said to be cofactor matrix, and we have to do transpose of this matrix. That is C11, C12, C13, C21, C22, C23, C31, C32, C33. This matrix is said to be adjoint of A by transposing the cofactor matrix. Now I will take one example. It is very easy to you understand. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it is very important. That is, I said minus 1 whole power j you have to multiply. After multiplying, it is the direct result, you can remember. That is, at what places you will get minus. At odd places you will get minus. What are odd places? Here the middle second element will be negative, the fourth element will be negative, the eighth element will be negative, and the sixth element will be negative. The remaining all elements are positive. So simply what you can do, you can write, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. The natural process, what you have to do, you have to find the minor of 1. You have to do minor of 1. You have to find minor of 2. You have to find minor of 3. Like this, every element you have to find minor. After finding the value of minor, you have to multiply with minus 1 whole power I plus j. But what I said, at second element, at fourth element, at sixth element, and the eighth element, you will get negatives. The remaining all are positive. So no need to multiply minus 1 whole power I plus j at their places. So, but this is a lengthy process. I will give one shortcut to calculate. But the traditional method is important to understand. What I said, you have to first find the minors of every elements, and after finding minors, you have to multiply with the minus 1 whole power I plus j value, and after multiplying every element should be arranged again, and that new arrangement is said to be the cofactor matrix. And if I do the transpose of that cofactor matrix, you will get the adjoint of A. The shortcut is simply for this matrix only. Now what matrix have you given? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose this is a matrix. For this matrix, what I have to do? I have to find adjoint of A. Now please listen carefully. That is 1, 2, 3. What is the short trick? Just rewrite the matrix 4, 5, 6, 7, 8, 9. Like this you have to write. Just repeat the row, that is a column. 1, 4, 7, first column, second column, 2, 5, 8. Now these two should be repeated. 1, 2, 3, 1, 2, 4, 5, 6, 4, 5. Now after writing like this, just eliminate the first column and first row, and these values will give the adjoint. That is, just cross multiply these values. This like this you have to multiply. You already know what order will be get. 3 cross 3. I am dealing with row. Suppose I have to find this value. That is 5, 6, 8, 9. How you can find cross multiply? 5 9s are 45 minus 8 6 are 48. What have you got? Minus 3. Minus 3 you have got. That minus 3 should be written first, and second element. This one you have to multiply now. That is 6, 4, 9, 7. 6 7s are 42 minus 9 4s are 36. So what I got? I got approx 6. So that 6 is dealing with the row. I am dealing with the row, but the value which you obtain should be written in column. 6 is obtained in this row, that is the first row, but I am writing in a column. do multiplication like this, but write in the column wise. Again, the third one, 4 8s are 32 minus 7 5s are 35. So minus 3. So minus 3 should be written not in a row, it is written in a column. Again, like this, 8 these are 24, 24 minus 18, it will be 6. And next, 9 1s are 9, 7 3 is 21, it is 12, write in a column. And 7 2s are 14, this thing, 7 2s are 14 and 1 8 is 8. 14 minus 8, it will be 6. Again, write in a column. And next, again this one, 2 6 are 12, 12 minus 15, it is minus 3. And again, 3 4s are 12, 3 4s are 12 and 1 into 6, it will be 6 again. And 1 into 5, it will be 5. And 4 into 2, it will be 8, it will be minus 3. So like this, do operation on row and write in a column. This matrix is said to be adjoint matrix, adjoint of given matrix A, direct shortcut. Now comes the important part, that is I already explained what is adjoint of a matrix. Now the properties of adjoint. Properties of adjoint, very important. That is, what is the properties of adjoint? Remember each and every property. That is, first of all is A into adjoint A. Adjoint A is same as adjoint A into A, that is equal to determinant of A into In. This property how to remember? I will explain what is determinant in the upcoming class, that is here in this class only, but after finding this one, that is A into adjoint A is same as adjoint into A, and it is same as determinant of A into In, the first property. And what is a determinant? Determinant just is value. In the minor calculation, you have find 1 2 3 4. Suppose if I take 1 2 3 4, what is the value here? Just cross multiply. 1 into 4 minus 3 into 6, it is minus 6, it will be minus 2. So this minus 2 is called determinant of this matrix. So that is a determinant. And what is the determinant of adjoint A? It is simply determinant of A whole power n minus 1. This results you have to remember. And what is the value of adjoint of AB? Adjoint of AB, same. In the transpose, what I said, AB whole transpose is B transpose into A transpose. Same here. Here also, adjoint B into adjoint A. Like this you have to remember. Next, what is adjoint of KA? That is, in the matrix only, if I multiply A, what is the adjoint KA? Adjoint KA is K power n minus 1 into adjoint A. Here, what is n here? Here, what is n here? These are order of A matrix. Just remember those values. Adjoint K is completed. Now, what is the determinant of adjoint A? Determinant of adjoint A is determinant of A whole power n minus 1 whole square. I already discussed what is the determinant of adjoint A. One adjoint A is n minus 1. Two adjoint A is n minus 1 whole square. And if I write like this, adjoint of adjoint A, if I do the determinant of these three, what I will get? I will get determinant of A whole power n minus 1 whole cube. Like this you have to calculate. And what is adjoint A? You already know. What is adjoint of adjoint A? What is adjoint of adjoint A? It is simply determinant of A whole power n minus 2 into A. Every property can be calculated here. Suppose if I want to prove this one, how I can do? This thing I have to prove. Just write the first, use this first one. This first one can be used, that is A into adjoint A is equal to determinant of A In. This is a property. What I have to do? I have to simply take the determinant here, both sides. So in this determinant property, it can be split into determinant of A into adjoint of A is equal to, in this value, in the determinant property, this determinant is a value. If I take value from the determinant, it will become determinant of A whole power n, and determinant of In, it will be 1. So now, what is adjoint A now? Determinant of adjoint A, it will be determinant of whole power n divided by determinant of A. So it will become determinant of A whole power n minus 1. Like this you have to prove. Every property can be proved by using this one, the first relation, that is A into adjoint A equal to adjoint A into A equal to determinant of A into In. I will take one example in the last, you can understand. Now comes the important thing, that is inverse. Inverse of a matrix. What is inverse of a matrix? Inverse of a matrix is defined by the term, that is A power minus 1. Inverse of a matrix is equal to adjoint of A divided by determinant of A. This relation is very important. By using this relation, you can find the inverse of a matrix. That is the first step, you have to find adjoint of A, and the second step is you have to divide with the determinant of A. And very, very, very important. How when will inverse of a matrix exist? Inverse of a matrix exist. When it will exist? It will exist when determinant of A is not equal to 0. That is, this denominator should not be equal to 0. What is denominator? That is determinant of A. Determinant of A should not be equal to 0. If determinant of A is not equal to 0, that matrix A is said to be non-singular. Non-singular matrix. Non-singular matrix, that is determinant of A. If determinant of A is equal to 0, it is said to be singular matrix. Singular matrix, just remember, I will repeat in a determinant also these topics, that is, if determinant of A is equal to 0, it is singular matrix. If determinant of A is not equal to 0, it is non-singular matrix. This is the thing. Now, there are so many shortcuts in order to find the inverse. The first shortcut you already know, that is, in order to find the adjoint A, I already said the shortcut, just divide with the determinant. And how the determinant can be calculated? For the 2 by 2 matrix, you can easily find, that is ABCD, the determinant is AD minus BC. But what is the case of A, B, C, D, E, F, G, H, I? This is a 3x3 matrix. What is the determinant value? Determinant is, I will say here only, determinant is defined by taking a row or any column, any row or any column, multiply each and every element in that row or column with the corresponding minors. What is the minor of A? This one. That is, A should be multiplied with E, F, H, I, this value. And next, the second value. I already said the second value will contain negative sign. Here negative, negative, negative. These places will be negative. So second will be again multiplied with minus with the B. And again, what is the minor of B? Minor of B is DF, GI plus C into this thing. The remaining elements are DE, GH. This entire value, this summation value is said to be the determinant of 3x2 matrix. Understand? Now I have to find inverse. Suppose I am taking ABCD 2x2 matrix and I have to find inverse of this matrix. The short trick is just interchange these values. Just interchange these values. That is, A will be shifted as D and D shifted as A, and this B, C should be reciprocal. That is, sign should be different. That is, B, if it is plus, it will become now minus B. If C is plus, it will become minus C. This is said to be adjoint. And if I divide with this, that is AD minus BC, this entire thing is said to be inverse of this matrix. This is a short trick. Suppose if I take example, that is 1, 2, 3, 4. What is this inverse? What is the inverse of this matrix? It is simply interchange. This value should be interchanged. That is 4 here it is 1, and here 2, here is 3. What I have to do? I have to change the sign, and I have to divide with the determinant. That is 1 into 4 it is 4, and 3 into 2 it is 6. That is minus 6. That is minus 2. So this is answer. And this is the inverse. And what is the inverse of diagonal matrix? That is ABC 0, 0, 0, 0, 0, 0. This is the diagonal matrix. For this diagonal matrix, I have to find the inverse. The inverse of diagonal matrix is simply again the diagonal matrix only, but the values now become reciprocals. That is 1 by A, 1 by B, 1 by C. There is no need to find the adjoint for this matrix because this is a shortcut. We have to divide with the elements in the given diagonal matrix. That is 1 by A, 1 by B, 1 by C. And here it is 0, 0, 0, and here it is 0, 0, 0. This matrix is called inverse of a matrix. Inverse of matrix A. Suppose this matrix is said to be A. This is the inverse of this matrix. And this is shortcut. And next comes the inverse properties. There are so many inverse properties. It is very important to understand each and every property. The first property you already know. Transpose of what is the transpose of A? That is A transpose whole transpose. What is the answer? A only. Like this, same here. What is the inverse of whole inverse? It will be A. This is the first property you have to understand. And second property is A into A inverse is equal to A inverse into A is equal to I. That is IN. That is A into A inverse. If I multiply A with its inverse, it will become the identity matrix. It is very important. By using this result, I will prove every property of this one. Now, what is the determinant of A inverse? It will be 1 by determinant of A. How this is possible? I have to use this relation, that is A into A inverse is equal to In. Now applying determinant. Don't muck up the properties. You have to, it is very easy to define properties, but you have to remember some properties which are very important. That is, this property should be important. You have to remember this property in order to derive the remaining properties. So remembering 7-8 properties is not that efficient. Remember just one property which is very important. That is, this property is very important. You can derive the remaining properties. So here I am using this relation to derive this relation. Applying determinant here, what I can do? A into A inverse is equal to determinant of In. And A into A inverse can be split as determinant of A into determinant of A inverse is equal to, what is the determinant of In? 1 0 0 0 1 0 0 0 1. What is the determinant? 1 into 1, that's it. So 1 into 1 is 1. So this value is 1 here. I have to find this one. So determinant of A inverse is equal to 1 by determinant of A. And what this can be written as A inverse is equal to determinant of A whole power minus 1. So this is a relation you have to understand. And very important, I already said what is orthogonal matrix. What is orthogonal matrix? The orthogonal matrix is A into A transpose is equal to A transpose into A is equal to I. This is a case. This is the orthogonal matrix. For orthogonal matrix, what is important thing? What is a orthogonal matrix? That is, you can easily understand. That is A into A inverse is equal to I am taking this relation A into A transpose. Sorry. What I have to do? I have to prove one relation. Applying inverse on both sides. Applying inverse on both sides. What I will get? I will get A into A transpose into A inverse is equal to I into A transpose. I into A inverse. Now here A into A inverse is I, yes, and here I into A inverse is A inverse only. So A transpose equal to A inverse. So this is a relation for orthogonal matrix you have to remember. Now again important, I already said AB is not equal to BA in general. Similar case, but कभी कभी हो सकता है AB is equal to BA हो सकता है कभी कभी. You have to check that case. That is 99% it is not possible, but some cases it is possible. So that is the reason I have written in general. Same thing, that is AB whole inverse is equal to B inverse A inverse. It is always true, but sometimes AB whole inverse is equal to A inverse B inverse also. Sometimes, not always. 99% cases it is not possible. That is, I already said the reversal properties in 3 different cases. I already said the reversal properties, that is AB whole transpose is equal to B transpose into A transpose. Here also AB whole transpose is equal to B, that is AB whole inverse is equal to B inverse into A inverse. But sometimes it may be equal to A inverse into B inverse. You have to understand. So that's it guys, the matrices has completed. Matrices completed guys. Now I am discussing the determinants. The matrices chapter is entirely completed. At the last I will do some matrices question in order to make you understand. Now I will discuss the determinants, very important. So what is meant by determinant? We already discussed what is a matrix. Yes, we already discussed what is a matrix. Matrix is a rectangular arrangement of the elements. Suppose if I give some elements, that is 1 2 3 4 5 6 7 8 9. Suppose these are the elements, and if I arrange these elements as a rectangle array, that is 1 2 3 4 5 6 7 8, and if I arrange like this, it is said to be a matrix. Now what is meant by determinant? Determinant is simply the value associated with the matrix. Every matrix has the value. The matrix is simply the arrangement, but the determinant is the value associated with the matrix. That is, you have to find the matrix, that is the determinant. The determinant is denoted as double lines, and the middle you have to write the matrix, that is A. It is said to be the determinant of A. It is called as determinant of A. Like this you have to write. This is said to be determinant of A. How determinant is calculated? The first case is 2 cross 2 matrix. I already discussed this one. A, B, C, D. How you have to do? I already said the determinant definition is you have to take one row or one column. You have to multiply each and every element in that row and that column with the corresponding minor. Suppose if I am taking this row, I have to take first element and multiply with the corresponding minor. What is the minor of A? Minor of A is D. So I have to multiply with D. And again I have to take second element. Second element is the negative. That is here if I write A11, here it is A12. 1, 2, if I do addition, it is the negative. So that is it is odd. So negative power, it will be negative. Negative power odd is negative. So AD minus, again we have to take the second element. I have to multiply with the corresponding minor. The minor of B is C. So AD minus BC. So this AD minus BC is the determinant value. Determinant value. This is the case for 2 cross 2 matrix. And what is the determinant for 3 cross 3 matrix? That is A, B, C, D, E, F, G, H, I. The determinant value is simply you can take any row. How many rows are present? 3 rows. 3 rows are present. How many columns are present? 3 columns. That is 6 possibilities are there to calculate. 6 possibilities or 6 possibilities are there to calculate determinant. But you have to take any one. You cannot take all the value, all the rows, all the columns. You have to take any row or column and multiply each element in that row and column with the corresponding minors. I am taking this row and I am taking the first element, that is A. Multiply this A with the corresponding minor. What is the minor of A? That is delete the column, delete the row. What is the remaining element? That is E, F, H, I. Next, the second element. The second element is present in the negative side. It will be minus B. Determinant of this thing I have to remove and this thing I have to remove. What are the remaining elements? These elements. So DF, HI. DF, HI. And next C, third element, that is plus C. Plus C, it is this element is A13. So it is the addition is even. So power of the negative whole power, that is minus 1 whole power 4, it is positive only. That is the reason we have taken plus C, and I have to take the minor of this C. Minor of this C is eliminating this column and this row. I will get DE, GH. So this entire summation is called determinant. Now I will take one example in order to make you understand. Suppose I will take the 2 cross 2 matrix, that is 1, 2, 3, 4. What is the determinant? Determinant is first you have to take the first element, that is I am taking this row, 1 into what is the corresponding minor? Corresponding minor is 4 minus second element multiplied with corresponding minor is 3. So what is the value? 4 minus 6, it will be minus 2. So minus 2 is called the determinant of this matrix. That is the determinant of this matrix. Now if I take 3 cross 3 matrix, what I will get? 1, 2, 3, 4, 5, 6, 7, 8, 9. I can take any row, any column. There is no restriction. 1, 2, 3. Suppose if I take this row, what I will get? First element multiply with the negative of these values. That is 5 9 is 45. 45 minus 48. Next, second element, that is minus 2 into minus 2 and crossing this one, I will get 4, 6, 7 and 7 9. So 4 7 are 28. 28 minus 7 6 are 42. And next, third one, that is plus 3 into, if I take this one, what I will get? 4 8, that is 32 minus 35. So this is a summation. This summation is called determinant. And if I do the calculation here, what I will get? 45 minus 48 is minus 3. And minus 2 into, what I will get here? Here 2, 14, minus 14. And here what I will get? Plus 3 into, it is minus 3. And if I do calculation, that is minus 3 plus 28 minus 9. What I will get? I will get 28 minus 12. I will get 14. Yes, this 14 is called determinant value. Determinant value. And here I can verify this answer by taking another row or another column. Suppose I am taking same matrix again. 1, 2, 3, 4, 5, 6, 7, 8, 9. But now I am not taking the first row. I am taking first column. to verify whether my answer is correct or not. Suppose if I take this column, remember what are the negative signs in the matrix? That is here negative, this is negative, this is negative, this is negative. So in that places only you have to multiply with the negative sign additional. So here first element is not negative, so 1 into I have element this one, I will get 5 9s are 45 minus 8 6 are 48. This one. Next second element is 4, but it is minus 4 into this one is eliminated 2 3 8 9. 2 3 8 9 is 2 9s are 18 minus 8 3s are 24. Next third element is plus 7. So here this one is eliminated, and you will get 2 6 are 12. 2 6 are 12 minus 15. If I do the calculation, that is 45 minus 48 is minus 3, minus 4 into here I will get minus 6 plus 7 into here I will get minus 3. So if I calculate, what I will get? I will get minus 3 plus 24. Here it is minus 21. Why? One second. Plus 24 minus 21. Once again guys, I am getting 0 here. 7 is multiplied 7 2 6 are 12. 12 minus 15, it is minus 3. Yes, it is correct. 4 it is taken as minus. 2 9s are 18. 18 minus 8 is 24. Yes, it is minus 6. It is plus 24. And the first one, it is 5 9s are 45. 45 minus 48, it is minus 3. So where I have did wrong? (32) minus 35. Yes, it is minus 3. 1 into 45 minus 48, it is minus 3 again. 2, it is minus 2. 4 9s are. Yes, here in this case I have done one mistake. 1 second. Here it is wrong. So simple mistake can lead to wrong answer. If I take 2 here, what are the elements? 4 6 7 9. So 4 9s are 36. 36 minus 7 6 are 42. So 36 minus 42 is minus 6. So minus 2 into minus 6, it will be plus 12. So here it is minus 9. Minus 9 minus 8 is minus 12. Plus 12 minus 12, it is 0. So the determinant value is 0 here. Here also, if I take minus 3 minus 21, it is minus 24. Minus 24 plus 24, it is 0. So same answer. So you can take any row or any column to find the determinant. Simple calculation here. But you have to remember the definition of determinant. What is the definition of determinant? The definition of determinant says that it is a value associated with the matrix, and its value can be calculated by taking any row or any column in the matrix and multiply each and every element in that matrix, that is in that row or column, with the corresponding minors of that matrix, that is minors of that elements. And now comes the properties. Properties of determinant. What are the properties of determinant? Suppose A is a matrix. Its determinant is defined as determinant of A, and there are some properties. That is, if I do the transpose of the matrix and find the determinant, it is same as a determinant of A, because the transpose of the matrix cannot give another matrix. It is the same matrix, but the row is become column and the column becomes row, and but the value will not change here. That is, the determinant of A transpose is same as the determinant of A. This is the first property. And the second important property, that is constant multiplied by A. It is defined as k power n into A. It is very important. That is, if suppose I already discussed in the matrix, if A is a matrix like 1 2 3 4 5 6 7 8 9, what is the matrix of 2A? That is, I have to multiply 2 with every element in the matrix, every element. But in the determinant, it is not that case. Suppose like this only, if we take 7 8 9, this is A, and I have to find 2A. But in matrices, in the determinants, it is not like that. The constant given is multiplied to any one row or any one column. That's it. It will be not multiplied to every element. That is, if I multiply with first row, I will get 2 4 6, and the remaining element same. I will not get any change. But here in the matrix, I will get the multiplication of every element. That is 2 into 1, 2, 4, 6, 8, 10, 12, 14, 16, 18. These two are not same. That is the reason matrices are different from determinant. In the determinant, every element is not multiplied. In the determinant, every element is not multiplied with the constant. Only one row or one column is multiplied. But in matrices, every element is multiplied with the given constant. So if in order to remove that constant, we have to do k power n times determinant of A. It is very important property. And determinant of AB. If the product, I can shift here, determinant of A into determinant of A. This is also important property. And next property is, what is the determinant of A power minus 1? It is 1 by determinant of A. How it is obtained? Because A into A transpose equal to I. And if I take modulus on both sides, what I will get? I will get determinant of A into determinant of A inverse by this property equal to 1, because the determinant of I equal to 1. So what is the determinant of A inverse? It is 1 by determinant of A, or you can write as determinant of A whole power minus 1. This is a property. This is a property of matrices. And next comes the actual properties. Basically, in the determinants, what is the difference between the matrices and the determinants? Determinants we have to solve and find the value. So in order to find the value, the approach should be optimal. That is optimal. Optimal approach you have to choose. So in order to choose optimal approach, why you are choosing optimal approach? Because in JMN's exam, you are getting only, for every bit, you are getting only 1 to 2 minutes or 3 minutes max. So in order to do the given problem in less amount of time, it is very important to solve the determinant before solving the determinant. Understand the line, that is, solve the determinant before solving the determinant. So why to solve the determinant before solving the determinant? Because in the determinant, we can have the advantage if there are 3 ones or 2 zeros. Suppose this is the determinant and 1, 2, 3, 0, 0, 1, 2, 1, 2, 3. Suppose this is the matrix. This is the determinant. I have to find the determinant of this matrix. We can use this column, this column, and just multiply this first element only. That is 1 into 3 minus 1 into 2. That is 3 minus 2. That is 1. Simple answer. There is no need to multiply these elements again. These elements we cannot multiply again, because these are zeros. The next elements are zeros. It is very obvious. So at one step you are getting answer. There is no need to again add another values. So 2 zeros are optional. That is 2 zeros are very important. We have to make it, and 3 ones are also very important, because by using 3 ones we can make 2 zeros. How I will explain now, by using the row or column transformations. Row or column transformations. It is very important. By applying row and column transformations, we can solve the given determinants. That is, suppose this is the matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. This is very important. Suppose this is a matrix. I have to make this 2 as 0 with the help of this one. So R2 at R2 and R3 I have to apply. That is R2 tending to R2 minus R1, or C2 tending to C2 minus C1. Like this you have to apply the row transformations. I will take one example. It will be very helpful for you. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. At a normal computation, you have find out the value is 0. That is the determinant 0. But with this again simplification, that is, if we can make this one 0 with the help of this one. How? R2 tending to R2 minus 4R1, R3 tending to R3 minus 7R1. How I written this one? Because R2 is 4, R1 is 1. So in order to minus, I have to multiply R1 with 4. But it is not the direct multiplication, because we are applying R2 and R3 transformation. So R1 is constant here, row 1 is constant. I have to write directly. But here 4 minus 4 into 1, that is 0. 5 minus 4 into 8, that is 4 into 2, it will be 5 minus 8, it will be minus 3. And 6 minus 4 is 12, it will be minus 6. Here 0, here 8 minus 7 is 14, it will be minus 6. And 9 minus 7 is 21, it will be minus 12. So like this, if I again, this is the matrix I obtained after row and column transformations. That is row transformation. Now in order to find the determinant, simple. That is 1 into minus 3 into minus 12, it will be how much? It will be 36 minus 6 is 36. So 0. So this is simple than this one. Opening entire one. That is 1 is multiplied with this one, and 2 is multiplied with this elements, and 3 is multiplied with these elements. So in order to simplify, it is very important for determinant to solve easily. And now comes the important property, that is a distributive property. That is, if a1 plus x b1 plus y, c1 plus z, a2, a3, b2, b3, c2, c3. If this is the case, this is the determinant. I can split this determinant as two determinants. That is a1, b1, c1. Take the first elements and write here, and this everything will be same. Entire thing, that is a2, b2, c2, a3, b3, c3, plus what are the remaining elements present? X, y, z. X, y, z. Here same, this should be same. This is a rule. When you are distributing the upper, that is the first row, it should be changed, but the lower should not be changed. That is a2, b2, c2, a3, b3, c3. This is the answer for this property. And there are some special determinants. The special determinants are 1, 1, 1, x, y, z, x square, y square, z square. I will explain this one. You will understand the next one. That is 1, 1, 1, x, y, z, x square, y square, z square. If this is a determinant, this entire answer is equal to x minus y minus z, and z minus x. How I obtain this one? By applying the row and column transformations. Simplification. You can directly open this one and you will get this one same. But at how much time you are getting it is also very important. Row and column transformation. If I apply this row and transformations, I can get answer within 1 minute. But if you open directly, it is taking 2 to 3 minutes in order to solve. So by applying row transformation, how row transformations can be applied? I have the main goal is to make this one 0. So how I can make this is 3 1. So it is very obvious. That is R2 tending to R2 minus R1, and another transformation is R3 tending to R3 minus R1. Yes. So here R1 is same because we are not applying any transformation to R1. R2 is R2 minus R1. So 1 minus 1 0, y minus x, and y square minus x square. And here it is 0, z minus x, and z square minus x square. Now open directly. That is 1 into multiply these two. That is y minus x is multiplied with z square minus x square minus these two should be multiplied. What I will get? I will get z minus x into y square minus x square. And again, if I clearly observe this one, it is simple as y minus x into z minus x into z plus x. And if I take this one as minus of z minus x, y plus x into y minus x. If I see clearly, y minus x, z minus x, y minus that is z minus x, y minus x, both are common. So y minus x into z minus x is common, and z plus x here, and here y plus x, that is minus y minus x. So minus x both are cancelled, and what is the remaining? Y minus x into z minus x into z minus y. And if I write this as improper, I will get x minus y. That is taking minus and rewriting, I will get x minus y, y minus z, and z minus x. This is same. These two are same. Like this you have to solve. And I will write some more important determinants here. 1, 1, 1, x, y, z, x cube, y cube, z cube. This answer is x minus y. You can prove this one. I will give homework to you. You have to prove this one. That is x plus y plus z. What is our extra term here? This is the extra term because it is cube. Here it is square. This is a difference, like this. And another important thing, that is we have to prove a square plus 1, ab, ac, ab, b square plus 1, bc, that is ac, bc, and c square plus 1. This is a matrix. You have to prove 1 plus a square plus b square plus c square. You have to prove this one. How you can prove? By using the row and column transformations only. You can directly multiply and you can prove this one, but it will take up to 5 minutes. But we have to apply row and column. We have to apply row and column transformation. So when you apply row and column transformations, how we can apply? Here if you see clearly, if I multiply a, that is the main trick here is I am rewriting again a square plus 1, ab, ac, ab, b square plus 1, bc, ac, BC, C square plus 1. The main trick here is I am unable to take A common here. So what I can do, I can multiply A here, I can multiply B here, I can multiply C here, and I will take common A here, I will take common B here, I will take common C here. So when I multiply, it will become A into A square plus 1 and A square B and A square C. Here I will get AB square, B into B square plus 1, and here I will get B square C, and I will get AC square, BC square, C into C square plus 1, and I am taking common A here. So these three will be common, and B will be common. So multiplying A and taking common A, it will be cancelled. So what I got A square plus 1, B square, C square, and again A square here, B square plus 1, B C square here, and here I will get what I will get. I have taken C common here, so I will get A square here, B square here, C square plus 1. Now very important, if you observe carefully, these three columns are same. So what I can do, I can take R1 tending into R1 plus R2 plus R3. Yes, if I do R1 plus R2 plus R3, there is a magic here, that is 1 plus A square plus B square plus C square. Again 1 plus A square plus B square plus C square. 1 second, I will write neatly. So if you observe, 1 plus A square plus B square plus C square, 1 plus A square plus B square plus C square, 1 plus A square plus B square plus C square. This thing I got, and the remaining things are same, B square plus 1, B square, C square, C square, C square plus 1. Yes, and from this row I can take common because it is same. So 1 plus A square plus B square plus C square is common. So what is remaining? It is remaining 1 1 1, B square plus 1, B square, C square, C square, C square plus 1. And if you solve this entire determinant, you will get one answer. And 1 into this thing, it will be 1 plus A square plus B square plus C square. Like this you can prove. Now comes the important part, that is solution. Solution for system of linear equations. It is very important. Linear equations. Solution for system of linear equations, very important. What does the linear equation says? What are the linear equations? Linear equations are a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z is equal to d2, d3. So these are system of linear equations. Now we have to solve and find the x, y, z values. How we can find? We can find this, we can solve the solutions, that is system of linear equations, by using the method called Cramer's rule. Cramer's rule. In Cramer's rule, what Cramer has said is, we have to represent the system of linear equations into a matrix. That is, the coefficient of x, y, z have to be represented in a matrix, and yz should be represented as another matrix, and the constants is represented should be another matrix. That is, what are the coefficients of x, y, z? a1 b1 c1, a1 b1 c1, a2 b2 c2, a3 b3 c3. And here in this matrix it is x, y, z. Here it is d1 d2 d3. This representation is said to be the Cramer's representation. Very important. Like this, every matrix can, that is, every system of linear equations can be represented. And after representing, what we have to do? We have to find the determinant of this first matrix. This matrix can be denoted as A, and it is X, and it is B. A into X equal to B. This is a form of the given matrix. We have to represent the given matrix as this form. And the A matrix, we have to find the determinant of A. And with this determinant, we can find the cases. This determinant of A is denoted by capital D. Remember, the determinant of A matrix is called capital D, and depending on the cases we can find. And we have to here find D1, D2, D3. What are D1, D2, D3? D1 is another matrix determinant, but here we have to use this third matrix in the first column. That is, first column is eliminated, and write D1, D2, D3. That is, it is called D1. It is called D1. That is, here it is D1, determinant of D1. D1, D2, D3, and the remaining are same. That is B1, B2, B3, and C1, C2, C3. This is D1. And what is D2? The second column should be replaced with the constant matrix. that is A1, A2, A3 will be same. Here it will be D1, D2, D3. Here it will be C1, C2, C3. This is D2. What is D3? The third column of A should be replaced with the constant matrix. That is A1, A2, A3, B1, B2, B3, D1, D2, D3. This all matrix. This one is called determinant of D3. This is called determinant of D2. This is called determinant of D1. And after finding D, D1, D2, D3, the value of X is said to be D1 by D, and the value of Y is said to be D2 by D, and the value of Z is said to be D3 by D. If you find these values, these are the solutions. That's it, the answer is over. This is the Cramer's rule. You have to find D, D1, D2, D3. I will give one example, it is very important. And if you find this XYZ, if I found any solution, it is said to be consistent. What is meant by consistent? If solution exists, it is said to be consistent. If solution exists, it is called consistent. Next, inconsistent. What is inconsistent? If solution does not exist. If solution does not exist, then it is called inconsistent. Consistent and inconsistent. If solution of the system of linear equations exists, it is called consistent. If solution of system of linear equation does not exist, it is called as inconsistent. Now comes important. I will explain in the example. You can catch them. And the next is homogeneous equations. And what is the equations are written here? What is the equations are written here? These equations are also called as non-homogeneous equations. Non-homogeneous equations. Non-homogeneous equations. Why it is called as non-homogeneous equations? Because the D1, D2, D3 are not equal to 0. That is the reason it is called as non-homogeneous equation. And what are homogeneous? And what are homogeneous equations? The homogeneous equations are having D1, D2, D3. Small d1, d2, d3 are 0. So A1x plus B1y plus C1z, A2x plus B2y plus C2z, A3x plus B3y plus C3z. These values, right side values is equal to 0. And remember one thing, in Cramer's rule, the right side of equal to should have the constant values only. If the equation is present like this, A1x plus B1y plus C1z plus D1 is equal to 0. This is not correct. You cannot implement directly. We have to just transfer D1 here. So A1x plus B1y plus C1z equal to minus D1. This is a correct representation of Cramer. So these are the homogeneous equations. This example is above Cramer's rule, but here it is homogeneous. In homogeneous, there are two important terms, that is trivial solution and non-trivial solution. Trivial solution and non-trivial solution. What is trivial solution? Trivial solution is x equal to 0, y equal to 0, z equal to 0. And non-trivial solution is infinite solution. Both are consistent. Here it is consistent. Here it is consistent. Now, why I am saying like this? In the before example, that is Cramer, what I said, x equal to d1 by d, y equal to d2 by d, z equal to d3 by d, I said. Now taking cases. First case, if d not equal to 0, if the denominator is not equal to 0, it having unique solution. If d is equal to d not equal to 0, it having the unique solution. And second case, if d is equal to 0, it having two cases. First case is infinite solution. Second is no solution. When you will get infinite solution? They are saying d equal to 0. So the denominator is 0, 0, 0, 0. And now the case will depends on entirely d1, d2, d3. If d1, d2, d3 will also 0, it is said to be infinite solutions, because 0 by 0, 0 by 0, 0 by 0 will leads to an infinite behavior. Will leads to an infinite behavior. will leads to an infinite behavior, that is 0 by 0. But in no solution case, any one of d1, d2 and d3 will be non-zero. If any of d1, d2, d3 will not zero, it is a no solution condition. And in the same thing, I have explained in the Cramer's equations. These are all related to Cramer. But what is homogeneous? In homogeneous equations, the constant terms are all 0. That is 0, 0, 0. These are d1, d2, d3. So we have calculated d1, d2, d3, capital D1, capital D2, capital D3 with the help of d1, d2, d3. But these are all 0. So if I observe in the previous one, the d1, d2, d3 here, capital D1, that is determinant of d1. If these values are all 0, 0, 0, 0, what is the determinant of this one? 0. Like this, what is the determinant of d2? It will be 0. What is the determinant of d3? It will be 0. So d1 equal to 0, d2 equal to 0, d3 equal to 0 in the case of homogeneous equations. So when I calculated x value, that is d1 by d, and when I calculated y value, d2 by d, and when I calculated z value, that is d3 by d. And when d1, d2, d3, that is the numerator is 0, the entire solution will depend on denominator. First case, what if d not equal to 0? If d not equal to 0, the answer is x equal to 0, y equal to 0, z equal to 0. This one I already said, this is trivial solution. And it is unique solution. Unique solution, and it is consistent. In the homogeneous equations, there is no solution case. Here definitely the solution will exist. In the second case, d equal to 0. If d equal to 0, again d 0 by 0, 0 by 0, 0 by 0. So it will be infinite solutions. And it is said to be non-trivial solution. And it is said to be consistent because the solution is existing here. So these are the things you have to remember. Next, last important concept. Guys. After this concept, I will discuss the questions. The last important concept is Cayley-Hamilton theorem. Very important theorem. The Cayley-Hamilton theorem bookish definition is like this: every square matrix satisfies a specific polynomial equation. That is, every square matrix will definitely satisfies specific polynomial equation. Every square matrix will satisfy a specific polynomial equation known as characteristic equation. Cayley-Hamilton theorem. Every square matrix can be definitely satisfied. That is, every square matrix will definitely satisfy specific polynomial equation known as characteristic equation. Suppose x square plus 3x plus 2 is a characteristic equation, that is a polynomial equation of a matrix A. This matrix itself is satisfying this equation, that is a square plus 3a plus 2 is equal to 0. This thing is called Cayley-Hamilton theorem. That is, the matrix could satisfy, that is, matrix will definitely satisfy its own characteristic equation. In the equation, polynomial equation only, it is satisfying A. That is, we can replace x with A. It is said to be Cayley-Hamilton theorem, and this equation is said to be that is a characteristic equation. For this also, I have one example I will discuss. Cayley-Hamilton theorem. So what this theorem says, in order to find the polynomial equation, in order to find, what you have to do, we have to use the matrix, that is A. We have to just simply do A minus lambda I is equal to 0. If you do this relation, A minus lambda I, what is A? A is a matrix, lambda into I times, that is I is also the identity matrix. That is, if the A order is 3, we have to take 1 0 0 0 1 0 0 0 1. This matrix you have to take, and we have to multiply lambda, and you have to subtract with A. If we find this, you are going to get lambda polynomial equation, lambda polynomial equation, and this polynomial equation will satisfy itself A, that is A will satisfy this polynomial equation. So this is said to be characteristic equation of A, and this entire theorem is said to be Cayley-Hamilton theorem. So that's it guys, the matrices and determinants chapter is completed. Now I will discuss some of the important questions. The concept is completed, and be ready guys. Pause the video and do the questions. The first question is number of all possible matrices of order 3 cross 3 with each entry entry 0 or 1 is option A 27, option B 18, option C 81, option D 5 and 12. When the question in matrix is given, it is very important to understand the question. What they are saying, number of possible matrices of order 3 cross 3. They only said the matrix is 3 cross 3, and 3 cross 3 contains 9 entries, that is 9 elements. And they are saying every element has 2 choices. Either it can be 0 or it can be 1. How many that type of matrices are possible? That is, this element has 2 choices, this element has 2 choices, every element has 2 choices. So how many different type of matrices are possible? Choices are multiplied 2 into 2 into 2 into 2 into 2, like this up to 2 power 9. So what is 2 power 9 value? It is 512. So the answer is 512. How I did this by using the permutations concept. The permutation concept says that the choices should be multiplied here. First element has 2 choices, second element has 2 choices, third element has 2, fourth 2, fifth 2, sixth 2, seventh 2, eighth 2, ninth 2. So like this, every element has 2 choices. So how many different type of matrices can be possible? 2 power number of elements in the matrix. Number of elements in the matrix is 9 elements. And how we can say the number of elements in a matrix? By just multiplying the number of rows and number of columns. If the number of rows is 3 and number of columns is 3, 3 into 3 it will be 9. So 9 elements will be present, and each element having 2 possibilities. So 2 power that number of elements. So it will be 2 power 9, and the answer is 512. Like this you have to solve. This is a matrix question. Now second question. Let the matrices, they given 3 matrices, A 2 1 4 1 and B 3 4 2 3 and C 3 minus 4 minus 2 3. What they are asking? They are asking to find trace of A plus trace of A into BC, that is ABC by 2 plus trace of A into BC whole square divided by 4 plus trace of A into BC whole cube divided by 8. This thing you have to calculate up to infinite times. It will goes on. This type of questions really have the pattern. You have to understand the pattern. Here it is trace A. Here it is trace A into BC. Here it is trace A into BC square divided by 4. So if you observe, 4 is 2 square, 8 is 2 cube. So there is a repetition of pattern here. So first of all, I have a doubt in B into C, because B into C is repeating. Maybe if I am lucky, it will definitely have some pattern. That is, I have to multiply B into C first. So what is B? B is 3 4 2 3, and what is C? C is 3 minus 4 minus 2 3. Yes, I have to multiply these things. What I will get, I will see now. 3 into 3 it will be 9, 4 into minus 2 it will be minus 8, and 3 into minus 4 it is minus 12, and 4 3s it will be plus 12, 2 into 3 it will be 6, 3 into minus 2 it will be minus 6, 2 into minus 4 it will be minus 8, and 3 into 3 it will be plus 9. When I solve, I have got 9 minus 8 as 1, here it is 0, it is 0, here it is minus 8 plus 9, it is 1. So this is the I value. So BC multiplication is simply I. So the entire problem is solved now. That is, this BC is completely I. This BC whole square is also I. One thing I forgot to discuss. That is I power anything. I power anything infinity will be only I only. It is very important. So it will be I. Again it will be I only. So I into any matrix will be that matrix only. So I can remove I also. So now the question has transformed to trace of A plus trace of A by 2 plus trace of A by 4 plus trace of a by 8 and up to infinity. And with the property of trace, what the trace property? Trace of ka is k into trace a, I already said. So trace a, trace of a by 2 can be written by taking common, that is by removing the constant, that is 1 by 2 outside and trace of a, plus again removing the constant trace of a, removing again constant trace of a up to infinity. Yes. Now entire trace a will be common. So trace of a will be common. What I will get? 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 and so on up to infinity. Now if I solve trace of a into what is this thing? It is infinite GP. What is infinite GP formula? First term divided by 1 minus common ratio. So it will be first term will be 1 divided by 1 minus 1 by 2 is a common ratio. What I will get? I will get this entire thing as 2 times of trace a. Yes, because 1 minus 1 by 2 is 1 by 2. This is 1 by 2 and 1 by 2, 1 divided by 1 by 2 is 1 divided by 1 by 2 is 2. So 2 times of trace a. So I got finally 2 times of trace a. What is trace a? I have to check the matrix. I already said what is the trace of a matrix. It is the sum of the diagonal elements. So 2 plus 1 is 3. So 2 into 2 plus 1 is 3. So trace of a is 3. 2 to is a 6. So the entire answer, this entire value in the question, this entire value what they asked, this entire value is now simplified to 6. So this is the answer. Like this you have to solve. Now the third question, let matrix A is equal to x, y minus z 1, 2, 3, 1, 1, 2. This is a matrix and they are saying x comma y comma z belongs to natural numbers. The first only given, and they are saying if adjoint of A 4 times adjoint and it is the determinant, this value is equal to 2 power 32 into 3 power 16. What they're saying then, number of such matrix A, is, we have to find the number of matrices. How we can solve? I already discussed this relation. That is, what is the determinant of adjoint A? It is modulus of, that is determinant of A whole power n minus 1. If it is 2, it will be whole square. If it is 3, it will be 3. So here it will be 4. So it will be determinant of A whole power n minus 1 whole power 4 is equal to 2 power 32 into 3 power 16. Yes. And they given this is a determinant of A whole power n minus 1 whole power 4, and they said this is a 3 cross 3 matrix. It is given 3 cross 3 matrix. So for the 3 cross 3 matrix, here n will be 3. So 3 minus 1 whole power 4 is it will be determinant of A. It will be 2 power 4. It will be 16 equal to 2 power 32 into 3 power 16. So what I can do? So here I have to solve this thing. I have to solve the power. Determinant of A whole power 16 is equal to 2 power 2 square, I think, whole power 16 into 3 power 16. So what I can do? So here by using this thing I can find determinant of A whole power 16 is equal to here 2 square into 3 whole power 16 I can write. 16 gets cancelled. So determinant of A is equal to 2 square is 4, 4 into 3 it will be 12. So determinant of A is equal to 12 we got. And what is the actual determinant? We have to solve by using this thing. So it will be x into 2 to the 4, 4 minus 3 it will be 1 plus y into it will be minus 1 here minus z into it will be minus 1. So finally we got x plus y plus z as determinant, and this determinant value is equal to 12. Now the question is this one, that is x plus y plus z is equal to 12. So x plus y plus z is equal to 12, we have to solve. x plus y plus z is equal to 12. This is a permutation question and they're given x, y, z values as xyz values as natural numbers. So this is a permutation concept. In the permutation concept, we can write as like this: xyz. This sum is equal to 12. So if these are natural numbers, what I can do, I can give 1 1 1 to every one. That is 1 1 1 will be given, and this 12 will be cancelled, and it will become 9. And we have to distribute 9 values to 3 people. How many partitions are required? 2 partitions are required. Yes, 2 partitions are required. So what I can do, I can add the value, that is what value I have to distribute, and number of partitions, and I can take combinations. So this is answer. That is 11C2 is the answer. That is 11 into 10 divided by 2. That is 5. That is 55. 55 different type of matrices are possible. Like this you have to solve. This is a permutation concept. If you didn't understand this one, there is no worry to this one, because it is very important. In this matrix question, the main concept is permutations. If you solve x plus y plus z is equal to 12, we can easily get, that is the 12, the xyz or natural numbers. I have to distribute 1 1 1 to everyone. If I distribute 1 1 1 to everyone, the value will reduce to 2. That is the value will be reduced to 9, and then 9 is should be distributed to 2 people. That is 3 people. 3 people I have to distribute. So in order to distribute to 3 people, how many partitions will be required? 2 partitions will be required. So the formula will be number of partitions plus what value should be distributed as a combination. That is 9 should be distributed to 3 people, and the number of partitions required by is 2, and C number of partitions, that is 2. So this is the answer. So this answer is 11C2, and 11C2 value is 11 into 10 by 2. It will be 5. It will be 55. Like this you have to solve. So the matrix questions are completed. Now comes the determinant questions. Determinant questions. I will discuss the most important questions here. The first question is, they given x minus 4, 2x, 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 x minus 4, 2x, 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 and x minus 4. Yes, this is the determinant, and this is equal to a plus bx times of x minus a whole square. Then one second, guys. Then what is a pair of a comma b? That is, we have to write a comma b, and the first option is a, b, c, d are 4 options, and the values are minus 4 comma 3 and minus 4 comma 5, and the third option is 4 comma 5, and the fourth option is minus 4 comma minus 5. Minus 4 comma minus 5. So how I can solve this question? This is a determinant, and after solving this determinant, so I have to open the determinant. So if I think logically, this determinant can be solved easily. That is, if you observe carefully, x minus 4, 2x, 2x, x minus 4, 2x, 2x. So this entire values can be added. That is R1 tending to R1 plus R2 plus R3. If I do this thing, what I will get? I will get 2x, 2x. It will be 4x, and 4x plus x, it will be 5x minus 4. 5x minus 4, and I will get 5x minus 4. And same thing, 2x, 2x, x minus 4, and 2x, and 2x, x minus 4. So this 5x minus 4 can be taken common, and I can solve the remaining determinant. But there is no need, because 5x minus 4 is, I can compare with this one. What I will get? I will get minus 4 plus 5x. If I compare, A is 4 minus 4 and B is 5. A is minus 4, B is 5. So option B is correct. So like this you have to solve. The first question of determinants is completed. Now the second question, they given let A equal to, they given on matrix 5, 5 alpha and alpha, 0 alpha, 5 alpha, and the third one is 0 0 5. So they have given like this, and they say if A square is equal to, determinant of A square equal to 25, then alpha equal to, here we can open this one, that is determinant of A is equal to 5 times of 5 alpha, that is 25 alpha is the determinant, and the given square of this value, that is determinant of A square is equal to 25, and A square can be written as A into A equal to 25, and determinant of A into determinant of A is equal to 25. Yes, so determinant of A square is equal to 25, and what is the determinant of A? It is 25 alpha into 25 alpha, it will be 25. So 25 is cancelled, alpha square is equal to 1 by 25, and alpha is equal to plus or minus 1 by 5. So answer is like this, and they said alpha greater than 0, so alpha is equal to 1 by 5. Like this you have to solve. And now I will discuss the last two questions, that is the system of linear equations question. They given the system of linear equations, they given as first equation, they given lambda x plus 2y plus 2z is equal to 5, 2 lambda x plus 3y plus 5z is equal to 8, and the third one 4x plus lambda y plus 6z is equal to 10. 6z is equal to 10. If this is the case, these are the system of linear equations. For this system of linear equations, what we have to do, we have to check at what conditions you are getting, at what value of lambda, what value of lambda we are getting unique, or we are getting infinite, or you are getting no solution. These conditions we have to check. First of all, what I said, I have to represent matrix as the Cramer's matrix, that is Ax equal to B. This matrix is said to be augmented matrix. And what is A matrix? A is the coefficient matrix, that is lambda 2 2 2 2 lambda 3 5 4 lambda 6 x y z, and the constant matrix is 5 8 10. So this is the matrix, and this is A, this is X, this is B, this is B. So I have to find the determinant of A. Determinant of A is determinant, that is denoted by capital D. So capital D is lambda times 18 minus 5 lambda minus 2 times 12 lambda minus 20 plus 2 times of 2 lambda square minus 12. Yes, I have to now open, that is lambda times of 18 minus 5 lambda minus 24 lambda plus 40 plus 4 lambda square minus 24, 18 lambda minus 5 lambda square minus 24 lambda plus 40 plus 4 lambda square minus 24. So 5 minus 5 lambda square minus plus 4 lambda square, it will be minus lambda square. 18 lambda minus 24 lambda, it will be minus 6 lambda plus 40 minus 24, it will be plus 16 is equal to 0. So finally I will get lambda square plus 6 lambda minus 16 is equal to 0. Yes. So what is a lambda? Lambda square plus 16 can be written as 2 into 8. So 8 lambda minus 2 lambda plus minus 16 I can write. Now lambda I can take common, lambda plus 8 minus 2 I can take common, lambda plus 8 is equal to 0. So lambda plus 8 is common, and lambda minus 2, yes, is equal to 0. So lambda is equal to minus 8 and lambda equal to 2. So for these two values, the lambda is the equation will become 0. Yes. So the value of D becoming 0 at these two values. So to get the unique solutions, the lambda should not be is equal to minus 8 and lambda should not be equal to 2. If lambda will not equal to minus 8 and 2, then the unique solution will be exist, because here D should not be equal to 0 is the main condition. And if lambda equal to 8 minus 8 and lambda equal to 2, for these cases you will get no solutions as well as infinite solutions. For no solutions and infinite solution, you have to check condition, but that is not asked in the questions. You have to just say at what condition you are getting unique and what condition you are getting infinite and no solutions. At a lambda equal to minus 8 and lambda equal to 2, you have to check. How you can check? You have to check d1, d2, d3. If all these three values will become 0, then the infinite solutions will be exist at these two values. If d1, d2, d3, if you calculate, any one of these value will not become 2, that is any of one of these d1, d2, d3 will not become 0, that is it is non-zero. If any one, at least one, then it will give no solutions. It will give no solutions. Very important. So this question is also completed. Now I will discuss the final concept, that is the Cayley-Hamilton question, that is a equal to 1 0 0 and 0 1 1 and 0 minus 2 4. This is a, and they given I. You already know how to find I, that is 3 cross 3 0 1 0 0 0 1 0 0 0 1. This is I. Now they given A inverse, they only calculated A inverse, that is 1 by 6 of A square plus CA plus DI they given. Now then they are asking, then find C and D. They are asking C and D values, and we have to find the solution. First of all, this is if you observe carefully, here they didn't said anything. Here I will give options also, A, B, C, D. The first option is minus 6 comma minus 11, and the second option is 6 comma 11, and the third option is minus 6 comma 11, and the fourth option is 6 comma minus 11. If you see the options, they are asking to find C and D values. But if you observe this equation is a polynomial equation with A as a variable. So what does it signify? This is the Cayley-Hamilton theorem problem. So for this A, I have to find Cayley-Hamilton theorem, that is polynomial equation I have to find. So in order to find polynomial equation, what I have to do? I already said you have to do A minus lambda I is equal to 0. That is, you have to find the determinant. So what is A? What is A here? The A is 1 0 0 0 1 1 0 minus 2 4. This is A minus lambda times of I. I have to multiply lambda to I. So this is the case, and if I do subtraction, I already discussed how to do the subtraction. So here subtraction is 1 minus lambda 0 0 0 1 minus lambda 1 0 minus 2 4 minus lambda. Yes, and I have to find the determinant of this matrix. Determinant, what is the determinant? 1 minus lambda into 1 minus lambda into 4 lambda plus 2. That's it. So 1 minus lambda into 4 lambda minus 4 lambda square plus 2. So 1 minus lambda into minus 4 lambda square plus 4 lambda plus 2. So you have to multiply complete, that is minus 4 lambda square plus 4 lambda plus 2 plus 4 lambda cube minus 4 lambda square minus 2 lambda. Now 4 lambda cube minus 8 lambda square plus 2 lambda plus 2. This is the answer. That is this is the polynomial equation. And here I can take common 2 also. That is 2 lambda cube minus 4 lambda square plus lambda plus 1. And this is a polynomial equation. Polynomial equation in lambda. Yes. But the matrix A itself will satisfy this equation. So what is what if I multiply this one? 2a cube minus 4a square plus a plus 1 is equal to 0. Now what is the required thing they ask? They ask A inverse is equal to 1 by 6 times a square plus ca plus di. A square plus ca plus di. Yes, I have to find this one. But here there is a cube. How I can do? I can multiply a inverse. So 2 into a cube into a inverse minus 4a square into a inverse plus a into a inverse plus a inverse is equal to 0 into a inverse. So here I can find 2 into a square minus 4 into a plus 1, that is I, plus a inverse is equal to 0. Now again I am multiplying this one, that is 4a square minus 8a plus 2i plus 2a inverse is equal to 0. I have to find a inverse, so I can take entire this one, that is minus 4a square plus 8a minus 2i, and I can multiply 1 by 2. I think I have done some calculation error. One second guys, I will do again, because this is not the required, because it is in the question they given 1 by 6 here, but we got 1 by 2, so there are some error. I can rectify it. A they given as 1 0 0 0 1 1 0 minus 2 4, this is a, and I have to minus lambda times of I, that is lambda 0 0 0 lambda 0 0 0 lambda. If I minus, that is 1 minus lambda 0 0 0 1 minus lambda 1 0 minus 2 4 minus lambda. This is the thing, and I have to open, that is 1 minus lambda times 1 minus lambda into 4 minus lambda. Yes, here it is a catch, that is 1 minus lambda. Here I written 4 there. When I multiplying, I have written 4 lambda. It is not 4 lambda, it is 4 minus lambda. So just the minus, the complete answer is changed here. That is 1 minus lambda into 4 minus lambda. We have to multiply, that is 4 minus lambda minus 4 lambda plus lambda square plus 2. And when I multiply this one, that is lambda square minus 5 lambda plus 6 with this one, lambda square minus 5 lambda plus 6 minus lambda cube plus 5 lambda square minus 6 lambda is equal to 0. So what is lambda cube here? Lambda cube plus 6 lambda square, 6 lambda square minus 11 lambda plus 6 is equal to 0. So if you observe carefully, now the matrix A cube will satisfy this one, minus 11a plus 6 is equal to 0. Now I have to require to find a square, so I will multiply with a inverse, entire thing into a inverse. So the right side will be 0 only, because 0 into anything is 0. Now if I multiply a inverse here, it will become a square. Here it will become 6a, it will become minus 11i, it will become 6a inverse. Now I have to find a inverse. What is a inverse here? I will transform entire thing to right side. What I will get? I will get 1 by 6 times of, I will get 1 by 6 times of a square, a square. Here it is minus lambda cube, I forgot it, but a square plus ca, that is what is the thing you will get here? If I transform entire thing here, I will get this is a minus a square, I will get plus a square minus 6a plus 11i I will get. So this is a inverse. But what actually they given? A inverse is equal to 1 by 6 times a square plus ca plus di they given. Now compare these two. 1 by 6 is same, a square is same, a is same, I is same. So what is d here? D is 11, and what is c here? C is minus 6. So c is minus 6 and d is 11. C is minus 6 and D is 11. C is minus 6 and D is 11. Option is C. C is minus 6, D is 11. C is minus 6 and D is 11. Yes, we are correct. So we have completed the determinants and matrices. That is the matrices and determinants. I said reverse. So the entire matrices and determinants is completed, as well as some PYQs which came very important, which are very important. These are the basic PYQs. There are really some awesome PYQs which you can practice and get the more confidence in matrices and determinants. But this is up to me. The entire concept is discussed here, and some questions are discussed. But you have to practice some more PYQs. The entire PYQs, if I practice here, the length will be going to 5 to 10 hours. So there is no use. You can watch the entire videos. So in order to maximize your productivity, you have to just listen the concept, practice some PYQs in the lecture, and after following the lecture, you have to practice some more PYQs which came in the recent years, that is 2021, 2022 and 2023. These 3 years PYQs are enough. So that's it for this video. If you like this video, subscribe to this channel and hit the bell icon. Like this, so many chapters are also coming in the row, and you can watch those videos also to gain more confidence in JEE Mains mathematics. That's it for this video, guys. Thank you.